In this video, we'll take a look at section 2.2, which is on functions and graphs. Our first objective is finding function values. But first, let's take a look at the definition of a function. A function is a correspondence between a first set, called the domain, and a second set, called the range, such that each number of the domain corresponds to exactly one member of the range. In other words, what this is saying is every x value corresponds to exactly one y value. Let's take a look at function notation. So we have f of x is equal to 5x plus 3. This means the same as y is equal to 5x plus 3. So over here, f of x, this is just equal to y. F of x is our y value. Now, we've seen this type of example before. It says, find the value of y if x is equal to 3 in the following equation. So we're given our value, x, and we want to figure out what y is equal to. So we're going to plug in our 3 for our x, and we'll determine what y is equal to. So we have negative 2 times 3, and then plus 3. Go ahead and simplify. We have y is equal to negative 6 plus 3, which tells us y is equal to negative 3. So we've seen that type of problem. Now with our next example, it's essentially saying the same thing, but it's written in a different notation. It's in function notation. So for this next example, find the indicative function values for the function f of x equals 2x squared plus 3x minus 4. So our first part, f of 0, essentially what we're given here is an x value, and we want to determine what our y value is. So f of 0, what we're doing is we're plugging in 0 for our x. So this is equal to 2 times 0 squared plus 3 times 0 minus 4. Now let's go ahead and simplify it. So we have 0 raised to the second power, which is just 0. So 2 times 0 is 0, plus 3 times 0, which is 0, and we have minus 4, which is equal to negative 4. So f of 0 is equal to negative 4. Now if I were to write this as an ordered pair, remember our x value goes first, our x value in this problem was 0, and then our y value is negative 4. Let's take a look at another one. So this time we have f of negative 5. This time we're going to plug in negative 5 for all of our x values. F of negative 5, this is equal to, let me go back so I can see the function. Okay, so we have 2 times negative 5 squared plus 3 times negative 5, then minus 4. Okay, let's go ahead and simplify. So you got to work out the exponents first. So we have negative 5 raised to the second power, which gives us 25. Now 3 times negative 5 gives us negative 15, and we have minus 4. 2 times 25, we have 50, minus 15, minus 4. Simplifying all this, so the 50 minus 15, that gives us 35. 35 minus 4 gives us 31. So f of negative 5, this is equal to 31. Next one, f of 2a. So this time we don't just have a numerical value to plug in for our x. This time we're given the term 2a to plug in for our x. So let's work it out the same way. We have 2 times 2a squared plus 3 times 2a, and then minus 4. Let's go ahead and simplify. So we have 2 times, now 2a raised to the second power, we have to raise the 2 to the second power, and we have to raise the a to the second power. So this gives us 4a squared. 4a squared, and then we have plus, so 3 times 2a gives us 6a, and minus 4. Simplify a little bit further, so 2 times 4a squared gives us 8a squared, plus 6a, minus 4. Okay. So this was evaluating functions for given values. Next objective, we're going to take a look at graphing equations. Graphing functions. Now, graphing functions, we're going to use the same method that we saw in the previous section in 2.1. We're going to create a table, find some ordered pairs, and then we can plot our ordered pairs and then draw a line through them. Now for this example, we have graph f of x is equal to x minus 4. Remember, f of x, this is the same as y. So what we really have is the equation y is equal to x minus 4. And now this looks exactly like what we saw in the previous problem. So let's go ahead and pick some values. Let's pick values for x, and then that will tell us what our y is equal to. So I'm going to go ahead and choose 0 for x. So now if I replace 0 for x, here, let me show you on the side. So we have y is equal to, I have 0 minus 4, which gives us negative 4. That gives me one ordered pair. Let's pick another value for x. Let's say 4. So I have y is equal to 4 minus 4, which gives me 0. That means my y value is 0 when x is 4. And now since this is a linear function, we know it's linear because the exponent for our x right here is just 1. All I need is 2 points and I could graph it. So let's go ahead and plot these 2 points. Okay, so we have 0, negative 4, which is right over here, and then we have the point 4, 0. Connect them together, and we get our graph. Let's take a look at another one. So let's go ahead and change our f of x to y. We have y is equal to 2/3 x plus 1. Now we're going to choose values for x. So I'm going to stick with 0 for my first choice because I want that fraction to cancel out, so it would make my life a lot easier graphing. So I have y is equal to 2/3 times 0 and then plus 1. Well, the 2/3 times 0 just gives us 0, and then plus 1 gives us 1. So now I have one ordered pair. Now I want to choose another value for x that's going to get rid of my fraction. Just go ahead and choose multiples of the denominator. So if I choose, say, 3 for x, I have y is equal to 2/3 times 3, and you have plus 1. So you have 2/3 times 3, which gives us 2, and then plus 1, which is equal to 3. So now that gives me another ordered pair. Now that I have 2 ordered pairs, I can graph it. Okay. So I have my first point, which is 0, 1. And then my next point is 3, 3. And now I have my graph. Okay. So now we have our next objective, which is using the vertical line test to determine if a graph represents a function. So now the vertical line test states, if a vertical line can be drawn and intersects the graph more than once, then the graph does not represent a function. So remember, our definition of a function is every x value has to correspond with exactly one y value. So we're given our first graph. So now it says, if a vertical line can be drawn and intersects the graph more than once, then the graph does not represent a function. So if I go ahead and draw a vertical line, notice it only intersects the graph one time. As a matter of fact, no matter where I draw my vertical line, it's still only going to intersect it one time. Since I can't draw a vertical line where it intersects the graph more than once, that means that this graph represents a function. Because every x value corresponds to exactly one y value. Let's take a look at this next one. So we have this weird looking shape over here. Now if I draw a vertical line on this side, it only intersects the graph one time. However, since there is a possibility for me to draw a vertical line where it intersects it more than once, for example, if I draw my vertical line right over here, now it intersects the graph at 3 different points. Since it intersects the graph more than once, that means that this graph is not a function. And let's go back to our original definition. Every x value corresponds to every x value corresponds to exactly one y value. If you take a look at this x value right over here, this corresponds to 3 different y's. And that's why this vertical line test works. It will tell us if a certain x value has more than one y value. So take a look at this next one. Okay, so if I just go ahead and draw my vertical line through the middle, it intersects it twice, which means not a function. Okay, now let's take a look at an application, a word problem. So the following graph represents worldwide gift cards from 2008 to 2018. This amount of sales in billions of dollars is a function of the year. Note that no equation is given for the function. Okay, just had to fix that typo. All right, so we're given this chart, and our first question here is, what was the total spent on gifts in 2014? Okay, well, let's just go to the year 2014, which is right over here. So we want to know what was the amount spent in 2014. Well, let's go up to see where it crosses, to see where our graph is. We have this point. So now let's line it up with the dollar amount, which is right over here. So it tells us 120. And what was this in billions of dollars. So the total amount spent in 2014 was $120 billion. So gift cards is the easiest thing to get somebody for a gift. Everyone's getting lazier, so we just resort to a gift card and save some time. Now, what was the total spent in 2011? Now, notice 2011, it's not exactly in our bottom row. But we know that 2011 is between 2010 and 2012, so it'll be about in the middle. Okay, so let's go up to see where our graph is located, and then we're going to go across to see what the dollar amount that was spent. So that corresponds to $100 billion. And now the last question, what is the trend of the graph? So let's go to the graph and then see what's going on with it. So from 2008 to 2010, we kind of had this constant number the amount spent on gift cards didn't change, but then it starts to increase as the years go on. Okay. So the trend of this graph is increasing as the years go on. So that was it for section 2.2. Remember, do not hesitate if you have any questions, just email me and I'll help you out.